three prototypes of visualization of SNMP traffic, which are visualizing network topologies, SNMP versions in operation at specific time windows, and observing the relationships of SNMP objects. Then I'll talk a little about my implementation and scalability issues, and then I will conclude and present the future of this lecture. Okay, so first, the network management area deals with large amounts of data. You know that some of its protocols and techniques are not completely understood when it comes to usage patterns and most user features. And there's a massive data amount involved in the process. We know that management traffic is really getting bigger and bigger, and it's kind of more and more complicated to understand what the patterns of network traffic are. So to try to understand a little bit more of the network management traffic, analytical processes may be employed over some collected practices of the protocols of management. And we can use information visualization techniques to aid on that, trying to get the achievement of new insights. And a part of it is the use of interaction mechanisms on these visualizations. But so far, the investigations related to network management analyze provided static visualizations with little possibilities of interaction. Try to show how this interactive visualization can lead to a better understanding of the network management protocols. We will study the SNMP, and our case study is SNMP traffic analysis and visualization. So, at first we've done some analysis. They were made as recommended by IRTF methodology for SNMP traffic management. And we tried to visualize three SNMP aspects, which were network management topologies, SNMP message inversions per period, and SNMP object proximity. And at first I will show you the three visualizations, and then I will show my evaluation of the three of them. I made an insight-based evaluation, which tried to answer these four questions. Do our proposed visualizations provide an accurate overview of the network management datasets? Can the network operator adjust the range of the visualization to fit his or her needs? To what extent of visualization techniques is the process of detecting patterns in the network management traffic? And whether we are using abstract representations to show the data. So first I will talk a little about the analysis made for the future visualization. The analysis were made following this RFC 5345, which is simple network management protocol, traffic measurements, and rate exchange formats. It's a systematic methodology for measurements and statistic generation of SNMP traces. And this methodology tries to identify some SNMP patterns. There are some of them. Frequent carried information by the SNMP, relationship between periodic and aperiodic traffic, the usage of obsolete objects, and popular mid definitions. We're trying to find the answer to these patterns. And there is a problem related to this methodology, is that it generates raw data in large amounts. So the results are usually presented on tables, which contains lots of data, and it gets really complicated to to obtain insights of this data just looking direct to the raw data. So we are proposing here the usage of some visualization techniques to aid on that. The first visualization technique that I will present is the network topology, network management topology. As you can see, we have here a presentation of agents, managements, and the relationships between them. Being the relationships, the flows which exist between manager and agents. So the managers are represented by the larger circles. The agents are represented by the smaller circles, and entities which appear as managers and agents are represented with the circles with the bigger radius. And those lines are exactly the flows that exist between them. So you can see that there are scales of traffic, which varies connections color scale and nodes color scaling, which represents the traffic which is passing in the nodes and between the nodes. So this technique is a combination of graph representation and complementary visualization, which can be switched between a scatter plot and a bar chart. So I'll present you a little video of how the interaction mechanisms can be used in this visualization. So as you can see, when some entity is focused, the neighborhood of it is highlighted, so the network manager can has this view of the neighborhood. Any entity can be centralized, which can provide a more, which can lead to a better identification of the role of this entity in the network. So as you can see, any of them can be centralized, either the agents or the managers. And then we can come back to the previous representation by this button, center network. We have this nodes and connections filters, which can filter all the nodes and connections based on the traffic of them to aid on the visualization of large topologies. So we can visualize only the nodes and connections which follow the filter. And now we also have the filter on the axis of the scatter plot, so we can visualize the nodes with similar characteristics. And we have this axis represented the connectivity, relation between the connectivity and traffic load. And we also have a bar chart which represents the traffic of the nodes. And we can also see that there is a brushing technique used, which highlights the focused bar on the top visualization. So it's get easier for the network manager to see it. Okay. Another highlight. You can also see the whole network here. And that's it. That's the network management topology. So I'm gonna decide this evaluation, as I said before. The conclusions of this evaluation are the following. First, as it comes to the overview of the visualization, we found that the topology got intuitive identification of the entities and connections with rated traffic load in the graph. The connectivity and traffic load relation between were represented by the scatter plot. It was the graph could not represent it very well, so we had to put the scatter plot to do it, and it managed to do it well. And we obtained useful insights about the management topology for end user interaction, which is pretty good. So far as adjustment is concerned, the nodes and connection filters were used, and they are useful in light topologies, as I said. It can be very hard to identify patterns when you have lots of nodes and connections, but you can try to see the only ones that you have more interest. So the analysis could be easier. Another interaction possibility is the centralization of the node topology, which provides a better understanding of the role of the centralized entity in the network. And we realized that there's overlapping of nodes in the scatter plot, which was solved by this interaction of filters restricting the axis range. Pattern detection of this visualization, we could identify two patterns, which were nodes traffic load and edge traffic load. We could identify in our research that nodes tend to form clusters of agents in the scatter plot, and managers usually appear far from each other. And when it comes to edges, we found that the similarity of flows between a single manager and its associated edges was something that we can see by the scatter. To end this visualization, the visual abstraction that we used was the following. The topology was represented as a graph, but we had this difficulty of comparing entities in proportional terms, and so there was this need to implement another technique, which was the scatter plot, where we used the same visual abstractions of the graph, like the same circles and the same colors, so which provides a better identification. And as you see, there is the possibility of pushing between these visualization displays, which leads to a better identification of the entities across the visualization displays. This is the second visualization technique that I implemented. It visualizes the SNMP messages exchanged in a graph. As you can see there, up there, there are the NOMS message, SNMP messages, which are defined in the protocol. As you can see there, these are filters, so we can see only the messages that the operator wants to see. Let me show you how does it do that. So as you can select only the messages that you want to visualize, and it leads to a more accurate identification of patterns. As you can see, the track message was not appearing at all in the graph. But as we filter down the other messages, it gets possible to visualize only the pattern of message exchanges of this message. It's really good, and it would not be possible without the interaction mechanism. Now we're going to select all of them back. And as you can see, the responses are really good, this implementation. And we can also use the versions division of the bar, where we can select only the SNMP versions that we would like to visualize. This is another iteration possibility. As you can see, SNMP v3 is not present on this traffic. Another interaction possibility is the semantic zoom operation. It's done like that, dragging the mouse from both sides. The right one zooms in the graph, and the left one zooms out. So when you select 1 or 2 days, the result is the visualization of all the corresponding hours of this day, as you can see. So we select the 22 day of April, and this is the result, the set of hours. And we can see all of them